Yes, let us begin, because those people who have joined now, let us respect their time because they have joined in time. So those who are following late, they can also view, but they may miss some of the portion. This is not a recording version. No recording was available for this session, and this is completely a live session. So I welcome all the attendees who are currently online and watching our session. This particular session is being hosted by the great Arvind Dhawan sir, who has tremendous experience in this field of HVAC and a great knowledge of electrical and how to apply in HVAC is very, very important, that he's going to give an insight of that. I welcome all of you to this session because you are willing to expand your knowledge, enhance your horizon, try to understand electrical, which is very important, and what is the importance of electrical and HVAC system. You know that what is the need of electrical, of what is the name of electrical, you know, what is the role of electrical, you know very well. Because if you do not know electrical, if you neglect electrical, the consequences on your career is going to be disastrous. Somebody is there in the market who is ready to replace you, who has electrical knowledge. So I am very happy to see that you are attending this session, because you know that if you upgrade, if you know electrical, at least we do not expect you to know entire electrical because knowledge is endless. But at least the electrical pertaining to HVAC or your field, if you're aware of, if you know, this is going to tremendously help you in your career. So again, welcome all of you, and I leave my baton to Arvind Dhawan sir.
Hello friends, welcome to the session. Now, the very first slide shows you what a plant room electrical system looks like. Okay. So now I'll start the slideshow. So this is what it looks like inside the plant room. And as we go along, I'll explain each and everything. Okay. Now, this slide shows you how the sequence of operations taking place. First, the main switch, then the condenser water pump, now the cooling tower, now the compressor, and the chill water pump. There is a sequence of operations inside the plant room. Okay. Now, I am Arvind Dhawan, subject matter expert, ESSCI, lead trainer level 6, ESSCI, faculty at HVAC, content writer for scholarly. Qualifications, mechanical engineering with specialization in refrigerant air conditioning, experience 45 plus years. Domains of experience, design, installation, service, project management, trainings, and content writing. Contribute in the following publication and HVAC contents: Handbook for Technicians, Air Conditioning by HVAC. This is available from HVAC website. Multi-scale Technician Handbook by Care Voltas, exclusively for Voltas. Trainers PPT, FTAC, and app contents for NSDC, ES under the Ministry of Skill Development and International Government of India. Revamping and refurbishing of course materials for HVAC. I've done a lot of revamping of work for HVAC. Multimedia contents on HVAC for Scholarberg International Private. Now, what is the objective of this session? The objective of this webinar is to create an awareness of importance of basic electrical knowledge for HVAC engineers. The air conditioning domain has many employment avenues that many of us may not be aware about. Thus, it is essential to understand this electrical subject for us to grow to our best potential. So I go to the next slide. Let me tell you something about the opportunities. These are the basic equipment of air conditioning. One is single phase, window AC, and mini split AC. In mini split AC, there are two, fixed speed and inverter split. Key role areas, installation and service. There is no design in such. These are all factory complete products sell out from the shelf. Industry requirement. What does the industry want from you? Okay. Basic HVAC knowledge is a prerequisite. Without that, nothing starts. One, good installation and service practices you should know. Two, management of service centers. Three, knowledge of safety procedures. Safety the three types, in fact 4 types: personal, mechanical, electrical, and fire. This is very important, fire. Then we have 3-phase AC equipments. In this we have duct split AC, package AC, VRV, or we also call them VRF, chillers. What are the key role areas? Design, concept design, detail engineering design, detail engineering piping, ducting, and electrical drawings. Mode of measurements, mechanical and electrical, POQ, specification, tender conditions. Then you have sales area, heat load estimation, POQ, mechanical and electrical. 3, costing and tender conditions. Then we have the installation areas. 1, knowledge of reading of equipment layout, piping, ducting, electrical drawings. Second is mode of measurements, mechanical and electrical. Third is knowledge of safety procedures, personal, mechanical, electrical, and fire. Last domain is service. Good service practices you should be aware about. Knowledge of safety procedures, personal, mechanical, electrical, and fire. These are the various key role areas where you have ample opportunities. Okay, but for all these key areas, the employer expects you to have these basic skill sets. Now we go to the next slide. So we are coming forward with a course on electrical essentials for HVAC engineers. This course, it is a very simple English voiceover. We have tried to communicate in the language you most comfortably can understand, and it is supported by very innovative animations. So one animation speaks 1,000 words. So seeing the animation and the little bit of voiceover makes things as simple as possible. So the major content of courses are Part 1, fundamentals, Part 2, measurements and testing, Part 3, motors, Part 4, main LT panel SLD, Part 5, controls, and Part 6, tender document. We have tried to cover the basic things that an employer expects you to have the skill sets and knowledge of these parts, these segments of the air conditioning engineering. So there are 3 basic elements required for any air system to function. What are the 3 elements? 1, mechanical energy. 2, electrical energy. 3, control energy. So you should have knowledge of these 3 domains applied to air conditioning. Mechanical energy. It is the mechanical force to compress the refrigerant. This is provided by a compressor. There are several types of compressors. These are shown below. Here are some of the compressors. Reciprocating. You can see the animation, it's working. You have the rotary compressor, you have the scroll compressor, you have the centrifugal compressor, and you have the screw compressor. All these compressors perform one basic function, is to raise the pressure of the refrigerant, number 1, and maintain circulation throughout the system. Electrical energy. Now to drive this compressor, electrical energy is required. This is a form of 1 single phase to 3 phase. The wave, sine waves of both are shown here. This symbol is that of a phase. Okay, when you see this, it means phase. 1 means single phase, 3 means 3 phase. Controls. Controls are required to ensure that the air conditioner performs according to the design parameters. 2, it is safe for the occupant. The air conditioning system should be safe. Safety first. Controls basically are the following types. 1, pneumatic, mechanical. 2, electromechanical. 3, electronic, mechanical. And 4, solid state electrical. All these controls require electricity to perform. 2 forms of electricity provided for controls: single phase AC and DC. We go to the next slide. So let's understand the basic things of electricity. Okay, most fundamental things we must understand. Like in understand language, you start with the alphabets. Or you want to understand English. So the teacher will first teach you alphabets A, B, C, like that. Then the teacher will say A for apple, B for ball. If you remember your childhood, this is how you are taught. And that was a rhyming form, like you're singing a song, A for apple, B for ball. But you've tried to implement that methodology here so that it is easy for you to understand and it makes it interesting for you to sit through the session and try to learn the subject, not be boring. So what is current? We come to what is current. When a pressure is applied, there are the orbiting electrons in the outermost orbit get detached, they become free and begin to move. The electrons in every element. So when you apply a force, this electron get detached and move from one atom to the other, like jumping over like this. Now, when they're jumping from one atom to the other atom, means a flow has started. It started flowing, like water is flowing. So the rate of flow of these electrons is called current. As simple as that. That is all you ought to know, that the rate of flow of electrons is called current. Okay. We go to next slide. Now, what is voltage? Voltage is the pressure that pushes the electrons to flow in a conductor. Electrons can't flow by itself. A vehicle, if you have a four-wheeler, you can't start by itself. It needs a self. It needs a kick. Somebody has to kick it. Either you push it mechanically or you have a self. And once the self is given through a battery source, then the vehicle starts starting. So to make these electrons move, you have to have some pressure, you have to have some force, you have to have somebody to kick the electron. That force of what pressure you applied to make these electrons to flow is called voltage, denoted by V. Then we talk about AC sine. This is what an AC sine wave looks like, right? If you assume position 0, then one side is positive, the next side is negative. And the number of times positive and negative happens in a second is called frequency. If it happens 50 times in a second, it's called 50 hertz frequency. Then the detailing is explained in the course itself. But this is how it looks like. And what is electric shock? We have just picked up some of the aspects of the course material to try to explain to you how we are going to teach you in that course element. See this electric shock, the current flows through this. It will only flow further down when the switch is on. It will go to the fan or the equipment or the motor case, maybe your fan, but it will not start. Then from the equipment, the current flow down, come back to the neutral. Only when it comes back to the neutral, that is, this will start. So what is phase, what is neutral, what is earth, what is electric shock? We have tried to cover it up because this is absolutely important for every HVAC to know. Now, if some current leaks onto the body, right? So that body is then grounded so that whatever leakage that happens and takes place in the equipment goes to the ground, does not go through the human person, human body that is touching the equipment. Then we talk about earthing. If it's going to the earth, it just can't just put it, dig a hole and put it. Then what is earthing? There are two types of earthing explained. One is plate earthing and one is chemical. And the basic fundamental is that you must have knowledge of using this instrument. This instrument, you can measure the voltage and you can measure the current and you can measure the resistance. There's a basic climb meter which should every engineer should know, whether it's mechanical or electrical. You need it in your everyday life, right? Now let me explain motors. You see, every equipment, air conditioning is all about motors. Compressor has a motor, blower has a motor, pump has a motor. everywhere there's a motor, then you have to know how motor works. What is the motor, right? So basically in air conditioning, we are using 3-phase squirrel cage motors, right? But now with the advent of star ratings and saving on energy consumption, then there are various types of motors have come into play, like BLDC motors. Now, in this slide, I'm going to explain to you how a 3-phase squirrel cage induction motor works. One, a motion motor requires 2 magnets. For any motor to work, it requires how many? 2 magnets. Magnets have the power to attract to each other and repel each other. Assume that we have a carrot and a horse. The horse loves carrot, okay? Next step. Now we hang the carrot in front of the horse. We will not give it to the horse to eat it, but we'll hang it in front of the horse. Then the horse will move forward to eat the carrot because it loves the carrot. Go forward. But when the horse moves towards the carrot, what we do? We move the carrot still further away. Then what will happen? The horse will again follow the carrot. If you repeat this process, then the horse will create a linear motion. He is unable to eat the carrot. He wants to eat the carrot. He'll keep following the carrot, will result in a linear motion. You understood that? It's very simple. Now suppose we move this carrot in a circular motion. Then the horse will also move in a circular motion. The horse will always try to get hold of the carrot, but he will fail to get hold of the carrot, right? And the horse will create a circular motion. Done? Now, we replace these carrots, a carrot in the horse, with electromagnets. Okay? Now there's no carrot, no horse, we have 2 electromagnets. Because the very fundamental working of any motor is the magnetic power, magnetism, field power of magnets. So we must have 2 magnets to create a motion. I'll explain. Either you can have a linear motion. A linear motion is used in relays, right? In solenoid valves. And a rotary motion is used in motors and pumps. Okay, gentlemen? Now we go to the next. A rotating magnet field is created in the stator of the motor. Now, what we are using is, we are using electromagnets. An electromagnet is a magnet that material becomes a magnet only when electricity is applied. When electricity is applied, that material becomes a magnet. When electricity is switched off, that material no longer becomes a magnet. These are called electromagnets. So, a rotating magnetic field is created in the stator of the motor. The stator is fixed into the body of the motor. So, the body of the motor is a stator and it has one electronic magnetic field. Then there's a rotor inside the center of that, which is supported on bearings. There are various laws of engineering regarding this, which you not go into that detailed engineering for electrical, but all you need to know that the stator magnetic field creates an induced magnetic field in the rotor. That is the end product. Okay. Stator magnetic field results in a magnetic field in the rotor. This resultant magnetic field is called induced magnetic field. Okay. Now we have 2 magnets. When you have 2 magnets, then the rotor starts chasing the stator magnetic field. And because the rotor is supported on bearings, then it starts moving, starts running after the magnetic field of the stator. And when it starts running after this magnetic stator, because the supported on bearing, it starts going round and round and round. So we get the rotary motion of the rotor. Is that clear, gentlemen? Now all this is written to you. Now, you must have finding it a little boring. I'll make it interesting for you. I'll come to the next slide. Now here's the horse, here's the carrot, right? When you move the carrot, the horse follows the carrot. See, it's going after, it's chasing the carrot, but it can't get hold of the carrot. So we have a linear motion. Now in this case, there's the carrot, right? We move the carrot, the horse chases the carrot all the way, following the carrot. The carrot is a rotary motion, so we have a rotary motion. There we have a rotary motion. And these are the magnetic field and stator winding. And this is how the rotary induced rotor magnetic field is shown. And this is how the rotor starts. This is what you ought to know, right? This is how it works. Now we come to the electrical panel. You see, you have heavy motors, pumps, compressor. How are you going to switch? You know, in your house, you want to switch on light, you have a small switch, tick, light is on, tick, light is off. Same with your ceiling fan, even for your ACs, right? But in huge machines, you have a huge electrical panel. The drawing below shows the arrangement of the following. I'll go step by step, okay? First is the outer enclosure. This is the outer enclosure. Thumb. Second is the main bus bar. Main bus bar. These are the copper bus bar or aluminum bus bar, the main conductors which carry the heavy current that will travel to the various equipments. Now we have main power indicators and a multifunction meter. So if you're going to have main power coming in, you ought to see whether it's coming or not. So we have three phases: red, light for red, it will be a red light. We'll have a yellow light for yellow phase. We have blue light for blue phase. And then we have a multifunction meter that will give you the reading the voltage, current, energy, frequency, and things like that. The multifunction meter. Then what we'll have? Then having brought this to this level, now we have to control it. It just can't go into the equipment. Control must be in your hand. So for that, we have a main incoming switch. That is the main incoming switch. That is, and once the main incoming switch is switched on, its lights will also come on. That means if these lights are on, that means this switch is on. You have alerted that the main power is on. If you switch this off, then these lights will go off. Is that clear? Be very careful. You can't play with electricity. It will not spare you. Then we have the main incoming cable. Now, if we have the bus bar, we have shown this, but how is it going to get the Bijli? How will get the power from? What will bring in the power? What will bring in the power is the main cable. Main incoming cable will first go to the switch, and from the switch, it will go and energize this bus bar, which will further give the power to your various equipments. Now we go to next slide. Interconnecting bus bars. There you are. Now the main cable has come. It is bringing the main power. You have the switch in your control. You switch this on. And when you switch this on, this will energize this bus bar. And from the bus bar, right, we interconnect whatever we want to interconnect. There you are. Induced switches with indicators for equipment. What will interconnect? These induced switches. Now these are various switches for one switch for one equipment. From this bus bar, the power will go to from the switch. From the switch, it will go to these bus bars, right? And then it'll go down to these bus bars, to this switch, all this. And when you switch on this, each switch, if it's switched on, its light will come on. If you don't switch on, this light will be off. Same with this switch, same with this switch, same with this switch, same with this switch, same with this switch. Okay. You always note in any air conditioning plant, you have an electrical panel inside the plant too. And you'll always have one spare feeder, one spare switch. It's always provided because if any switch gets damaged, you have a spare feeder to take care of that equipment. Outgoing cables. Now the switch is there, but the equipment is not getting the power. The equipment will get the power from outgoing cables. Now every switch have an outgoing cable to the respective equipment. In the previous slide, I shown you main switch, compressor, right? Then condenser, then cooling tower, all these are switches. And from the respective switches, the cable will go one to the compressor, then one will go to the cooling tower, one will go to the condenser, as the case may be. And finally, you will have a flow stand. You just can't keep it like that. The cables are going to enter from the bottom. The cables normally enter from the bottom, right? Okay. If you enter from the bottom, or if you're not top, right? If you're entering from the bottom, then you'll have to have a flow stand. It should be at least about a foot, 12 inches or 2 feet, depending on the number of cable and the size of cable. Because cable entry from the bottom is very simple, because cables are coming from the main cable, incoming cable is coming from outside. This is normally it's coming underground. Coming underground, most cases comes underground from your transformer room, and it will enter from the bottom. It's very easy to enter from the bottom because the cable is already underground. So this is the panel. It will be standing on the floor, so you'll have a flow stand. There is the flow stand. This is what your main panel looks like, and this is how the power is distributed to various equipment inside the plant room. Now we have controls. Okay. Now the phase is present at one end of a low volt coil. Now I'll explain to you what it is. Whatever you want to control, right? Suppose I want to control this compressor motor. So there I have one starter, which can switch on, switch off. Then I'll have one thermostat. Then I'll have one HPLP switch, and I'll have oil pressure switch. Now, all these controls have mechanical contacts, which are normally open or normally closed, as the case may be. Right? Now, to control this, how to control this? They're all connected series to a no volt coil. This is a no volt coil. I explained to you, when I come to this portion, I explained to you how magnetism in linear application takes place. When this becomes a magnet, this will pull this plunger. When it pulls this plunger, these contacts will close this line, close this line, close it, and the compressor will start. So this is the linear application of a magnet application, how it takes place. And this will be that rotary motion. Now let me give you the supply. Now I switch on. Starter, I switch on the starter. What happens after I switch on starter? The power from the phase comes here to this no volt coil. Here it comes. It passes through the no volt coil. Then it passes through all the switches, switch contacts. But the coil does not become a magnet till such time it gets the neutral. And once it gets the neutral, I showed it, it comes here, neutral, it becomes a magnet, and it pulls the contacts, and this motor starts. So any of your switch malfunctions, suppose the oil pressure is low, this will disconnect this circuit, this coil will not get the neutral, it will become de-energized, this will no longer become a magnet, and the compressor will stop. Because of oil pressure switch. And every switch has auxiliary contacts through which we can give a supply and an indicator. So if this is a failure, this light will have its own light, it will switch on, the compressor will stop, because the no volt coil is circuit of the no volt coil is no longer completing. Same applies for HPLP switch. Suppose there's high pressure, same thing. So any of these contacts will all be in series. All these are safety devices. Any of these elements are endangering your equipment, they will switch off the compressor. The main starter can have a thermostat and various other controls you will like to have. This is how we control our air conditioning plant. Now I'll explain to you how a thermostat works. I mentioned that thermostat very simple. Okay. Now here is a thermostat. You just take a look at this first. Take a look what's happening. Having seen it, now let me explain to you. So I'll go off to the explanation after you take a look at this. What is happening? This is moving. This is moving. This. There's one fixed contact, moving contact. Moving contact moves away from the fixed contact. And this is one tail out here, something out here. This is a thermometer showing the temperature going down. This is a cooling coil and this is a blower. Now let me start the explanation. A thermostat has a bellow filled with the refrigerant in the air conditioner. So if your air conditioning system is running on R22, this is a bellow in the thermostat. It will be filled with R22 only. If it's R134A, then this bellow will have R134A. If the bellow is 410, then it will have 410A, whatever the gas may be. And this is a small capillary, this capillary, and there's a bulb. This also contains the refrigerant that is inside the system. So the bellow and this tail are interconnected through this. So there's gas all along this bellow and they call the thermal bulb. Now, this bulb is placed at the return side of the cooling coil. When the room air will go over this bulb and through the cooling coil, and so that it will sense the return air. That will send the environment condition, and accordingly, it will affect the movement of this thermostat. So we'll go to the next point. The bulb senses the temperature of the return room air before the cooling coil. I've already told you that. When the temperature falls, the refrigerant contracts. This causes the bellow to contract. So when the temperature goes down, this gas inside contracts, volume reduces. Because you all know pressure and volume are interrelated. Pressure increases, volume increases. Pressure reduces, volume reduces. So when the temperature goes down, volume goes down. When the volume goes down, this bellow contracts. When this bellow contracts, what happens is there's a moving contact attached to this bellow. So when the bellow contracts, it moves away to the left and away from the fixed contact, and these two contacts come apart. And through these contacts, we control that equipment. So when the contacts are closed, your equipment is running. When the contacts are open, the equipment stops. How it moves away? Because of the temperature of the room. This bulb senses the temperature of the room, and accordingly, this bellow moves forward and back. Is that okay, gentlemen? Now we go to the next slide. This is how a thermostat works. Because if you're an air conditioning engineer and you have this application there, in place of thermostat, there are other controls, like you have a TEV with external equalizer, then TEV also has a bulb. And what happens if the bulb breaks? If this capillary gets punctured, what will happen? You should know, because your machine is not going to work, right? And if you're going to buy a substitute, you should know that you have to have a thermostat or the TEV which is suitable for this particular gas. You can't have, if you have a system of R22, you can't buy a TEV suitable for R410A. Just cannot. Or 134A, you just cannot. It won't work because the system gas and the gas in the controller must be the same. So this you ought to know, that if this gets leaked or gets punctured, you have to replace that control. Okay, gentlemen, now we come to next. The reverse happens when the temperature rises. As I explained, movement depends on the contraction, and contraction depends on the temperature, whether increasing or decreasing, as the case may be. Then we have another control called the thermal overload. Suppose your motor is defective, it draws more than the normal current. What happens? We need to switch off that motor. There must be a safety device which will protect my motor from catching fire because of heavy current or cables getting burnt out because of heavy current. If we have a motor, it has a limited current to be drawn. If the current drawn is more than the normal, for example, you take a sealed system, right? What happens is ambient changes, right? If I have a AC in, let's say, in Mumbai, and I take the AC and fix it in Rajasthan, high temperature, what will happen? Compressor may draw extra current. If that extra current is beyond its limited, its set parameters, then my compressor should stop, should trip. This is called trip. What happens is, when overcurrent goes, there's a heating coil inside this overload. It starts getting heated up like a heating element. And when this heating element gets heated up, this is a bimetal. Bimetal expands and contracts by virtue of the change in temperature. So when this bimetal gets heated up, this contact opens. When this contact opens, your equipment stops. And it will restart only when it gets cooled down. This is a typical example what you have in your small equipments like window ACs and refrigerators. Now that too now we change. We have our latest model, like we use simple thermistors. I'll come to that. Take a look at this. Heating starts. Okay, the heating starts. When the temperature reaches 125 degrees centigrade, right? What happens is, this bimetal will move like this. It will move away. This contact will open. Once this contact's open, it disconnects the supply to that equipment, the compressor, whatever the case may be. And when you disconnect supply, then heating stops. Then heating stops, cooling starts. Cooling starts, the bimetal gets cooled down and close the contacts when the temperature is 65. Typical application for a refrigerator. It can be applied same with air conditioners. But this is now old. The new things what we are using now is thermistors.
Sir, I just interrupt for a minute over here.
Yes,
those
sir.
who have question, they can type it in the chat and question answer. So as the session ends, we will take one question one by one.
Shall I continue, sir?
Yeah, continue.
So if you see, I've shown you, I've made a nice GIF out here. It's repeating itself all the time. Having read this, if you've not understood it, you don't have to repeat the thing. Just take a look at this. Heating element, 125, cooling starts, close contact, 65. And repeat itself, right? So that the thing becomes for you, once you have understood it, then you can go to the next slide. So let's keep your slide and read the contents and see this GIF. Now, temperature sensors. Nowadays, we all have sensors now, like even your window AC has sensors, everywhere we have sensors. We have switched from electromechanical to electronics mechanical, right? So there are two types of sensors basically used in air conditioners. How many types? Two types. One is NTC. This is called negative temperature coefficient. These are semiconductors, thermistors. This is for low temperature application. Second is PTC, stands for positive temperature coefficient for high temperature application. What exactly is NTC or PTC? It is a semiconductor called thermistor. In a thermistor, the electrical resistance changes with the temperature. Now take a look at this. It's a simple circuit. The current will flow right through the circuit depending on the resistance. Now take example. Let's take an example of a toll. The toll, right? The traffic is going. Can I draw it for you? Pointer option. Okay. Suppose we have a toll. Your toll, the traffic going like this, right? So if this toll is closed, traffic can't move. The toll is open, the traffic will move, correct? So this is the resistance. This gate is the resistance, okay? When this gate opens, traffic moves. When this gate closes, traffic stops. So this resistance, right, is like your gate. Now, how you can operate the gate? You can have a guard, you can have physical guard out here, right? He sees you coming out in your car, he'll open this gate mechanically. When you leave, you're gone through, he'll close away. That is one method. Now, we have sensors. We have photo sensor. We have seen you. The sensor has seen you. And once it's seen you, it automatically opens the gate. And once you've left, sensor no longer sees you, it closes the gate. Similarly, this resistance, right, the value changes according to the temperature. So if the temperature goes down or goes up, this resistance changes. And when this resistance changes, instead of this traffic, you have current. There you are. Now this current will flow through this resistance, right, depending on the temperature. And when the current flows or ceases to flow, we can operate our devices. As simple as that. Is that clear? So let me go to the pointer options and go back to laser pointer. Okay. I'll go to next slide. There you are. Take a look at this very carefully. NTC tensors. In an NTC sensor, what happens is that when the temperature increases, the resistance reduces. Okay. So if you apply voltage at one end of the NTC, the temperature is low, this voltage will not go through this. Right? Putting hand up there. Not allowed, you cannot go. Too cold, not allowed. And when the temperature rises, then look at this person, then the voltage passes through this. And when the voltage passes through this, you can operate whatever device you want. This is how the sensors work. And all our air conditioning applications, we use NTC sensor. NTC means that the resistance decreases when the temperature increases. So if the room temperature increases, right, we will switch on or we will operate the controller, which may be whatever it may be as the case may be. Okay. I hope that is simple and well understood. Now take a look of a working of a sensor control system. Now complete system is explained to you out here, right? In an NTC thermistor, the resistance reduces when the temperature increases, which I've already told you. So when the room temperature increases, the resistance reduces, the positive potential passes through sensor and activates a transistor. The circuit between the positive and negative is completed. So once, what we do is, once the voltage flows through the NTC, we energize a relay. Electronically, we energize relay. That is done through a transistor. IC is multiple transistors. What happens is, in simple language, when the temperature increases, the resistance of the NTC decreases, it permits the voltage to pass through it, and it goes through the electronic device, IC or the transistor, the case may be, and it energizes the coil. And once the coil gets energized, it becomes a magnet and it closes a mechanical contact, right? So in a sensor-based control system, there are two circuits. One is the control circuit, which you can see here. This is the control circuit. And the second is the power circuit. The power circuit. Power circuit has got nothing to do with the control circuit. The control circuit is just to sense the temperature and energize the relay. That's it. Over. Then we have auxiliary contacts. These contacts have got nothing to do with this relay. When the relay gets energized, it pulls the plunger, which has a moving contact. When the plunger is attracted by the coil, its moving contact closes this circuit, this AC circuit, and starts the compressor. This is the power circuit. Okay. This is a mechanical movement, electrical movement. Is that clear now? This is how all our systems work, no matter what it may be. This is the basic fundamental. Whether it's your refrigerator, whether it's air conditioner, whether it's water air conditioner, central plants, whatever the case may be. So we have covered basics. I'm sure it must have been enlightening. But now you see, if you're in the construction field, you're an air conditioner, so you'll be installing the mechanical parts. You install the chiller, you install the pumps, you'll install the ducting, install the HU. But what about the electricals? None of the thing will work without electricity. And this is an integral part of the complete project. You can't wash your hands away by doing the mechanical part. Till the electrical part is over and the system is commissioned, you are not free to leave the site. The project is not over. The project is over when the electrical section is completed, then the mechanical. So the mechanical guy waits for the electrical guy to do its job. The electrical guy does not do his job or is delayed, the mechanical guy has to wait. The project gets delayed. You are so dependent on the electrical person, so dependent on him that you cannot move an inch forward without this electrical support. Only when the electricals are complete, then you restart your work. First you install the things, then you have to relax because you can do nothing. Then the electrical work is completed, and then you have to restart. Okay, then you have to start commissioning your equipment. So in any tender, air conditioning, or any project, you will have a tender document with bill of quantity called BOQ. You'll have the mechanical section and you'll have the electrical section also. So if you open a tender document, you come across this 3.5C, 240, XLPE, ACB, PCB, MCB, MCCB, TPN, VSN, VAF, what is all this? So if you are a construction engineer, commissioning of the project is only said to be commissioned when the electrical is also completed to the satisfaction of the tender conditions. Very important to know, understanding the tender conditions. Instead of 3.5C, you put 3, what will happen? Instead of XLPE, put something else, what will happen? Right? Instead of MCCB, he puts MCB, what will happen? Let's understand some basic things. All these SP, DP, TP, TPN, they're all switching devices. And as you go up, as you scale up, the devices changes because current capacity changes. And SP, you can't use an SP for 400 amperes, just cannot. It blow in on your face. SP is for low rating. It is called single pole. That means it is meant for single phase. Double pole, phase and neutral for single phase. TP, triple pole, means you will have to control 3 phases. But controlling 3 phases is not sufficient. A 3-phase supply is a 4-wire system. Phase, red, Y, E, and a neutral. It's a 4-wire system. So let me explain this to you. That is single SP is single pole, DP is double pole, TP is triple pole, and TPN is triple pole with neutral. So before you set up anything, you must understand what is phase and what is neutral and what is the difference between the two. What happens if the neutral is loose, not broken, loose? What will happen? What will happen? Huge damage will take place. Huge. If it is broken, yeah, you say, yeah, but things will stop and not, but that's fine. Suppose it's loose, what happens then? Then you come to, in the tender document, there's a lot of cables. Now, cables are a very expensive component, right? Now, you see, here it is written 325 plus 16. I've given you one example from the manufacturer. You have to refer to the manufacturer, right, of the ratings to check whether the material delivery site is matching with your requirement. So, in this case, I've written AFFY, right? Aluminum conductor, PVC there, flat steel wire, armor, PVC shaded. Okay? It can be XLPE. XLPE means it's a type of PVC overhead, cross-linked polyethylene. So that is the name of the insulation on the cable. In a 3-phase system, right, you will have 3.5 cores or 4 cores, right? I have given you 3.5 cores because all your equipment will be more than 25 amperes. Below 25 amperes, you will not get 3.5, you will get 4. So let me explain what it is. This is core. This is the size of each core. And this is half core. Neutral is always the half of the total core size. Okay. Now here is what a cable looks like. We have 1, 2, 3 full cores, big size, and 1 half core. So you have the full core, half core, the full core, PVC cover, right? PVC over the core. Then we have another sheet over it. So the first coating of PVC, then a second coating of PVC. Then we have GI armor. What is this armor? All cables, irrespective size, will have this size, 4 into 0.8 mm GI flat armor. Why is this armor required? Because if you're laying the cable underground, if there's traffic over it or gardener is doing something, this armor is to prevent this cable from getting damaged from mechanical damage. Any mechanical thing, hammering or traffic or what, mechanical pressure, this cable will be protected because it's extremely expensive. Okay. Now, you must know you'll have cables without this and you'll have cables with this. If it is external cable, you must have armored cable to prevent damage. But if you have cabling inside the plant room, inside the building, then this armor is not required. So there's a cost saving out here, cost difference. All of a difference between the armored cable and an unarmored. Where to use this armored cable and where not to use the armored cable, you should be aware of it. It has a cost factor. We come to next point. Now, you have construction taking place, right? You're an AC guy. Now, piping drawing, that you know what to do. You know the symbols of the piping, if you know the symbol. Because if you're executing a project is executed on based on what? Based on drawings at site. You get drawings first, you get concept drawings, then you get drawings fit for construction drawings, right? Then after construction, you get as-built drawings. So 3 sets of drawings are there. One is tender drawing. You should know that that the topic by itself, understanding tender document. First, the consultant or the engineer, as the case may be, will give you tender drawings, right? After that, the contractor will give as-built drawings after the job is done. After the tender is awarded, right? You will get again, the consultant or the engineer will say, but this drawing is fit for construction. Tender drawing and fit for construction drawing may be different because between the construction and the initial floating of tender, a lot of discussions takes place. Building orientation may take change, requirements may change. There will be a lot of discussion between the consultant and the user. And finally, when everything is frozen and done with, then the consultant will give fit for construction drawing issued to the contractor for execution. Execution is never done based on tender drawings. So after all the discussions, fit for construction drawing is given. It may be the same as tender drawing, maybe it's slightly different, but normally changes happen because the client may have certain other views in the course of discussions and change in requirements. So once the project is over, then the contractor issues as-built drawings, right? As-built drawings may not be identical as fit for construction, right? Because during the construction stage and the process of construction, a lot of meetings takes place because of hindrances, problems coming at site, right? There are so many elements working together. You have a mechanical person, electrical person, firefighting person. 3 basic elements. Ducting is crossing the firefighting pipe. Firefighting is crossing electrical cables. And once that all that things place, they may not be identical. So whatever the changes may take place, then the contractor prints out as-built drawing, which is given to the client and for his operation staff to take care of the systems. So if you have the drawing, you should understand what is all this.
How many slides are remaining? So I was planning to take the Q&A session, question and answers.
Okay, sir, not too many. So I will show what is this fuse, VSS, all this thing already explained, and the symbols you ought to know. This is what is it? Symbols, right? This is MCCB. MC is molded case circuit breaker. MCB is religious circuit breaker. Then understand electrical section of tender documents. Already covered all this. What is this? What is IP54? You can IP54. It has a cost implication. It is a type of protection. Then you have what is this? What is this? What is this? Cables. What is this? What is this? What is this? So my point is that when a construction engineer, if he's aware of all this thing, it adds value to his work. So that completes this session. Neeraj, now you may take over.
Yeah, I would like to answer the questions what has been raised.
Okay,
so
sir.
I request all of you to participate in Q&A session and type the questions and ask us. Don't be afraid that your question is silly or not. You're all are knowledge seekers. So if you have any topic regarding HVAC related electricals, please ask us. So we are ready to help you and answer your questions one by one. We are happy that you are participating in this, so you want to learn about the electricals. And the last chapter which Mr. Dhawan sir has told, that is tender document. If you are getting a tender document, now you can easily correlate the terms, what is being taught or covered in this session, that what is XLP, what is 3.5, 4, so that you can easily correlate. So I'll just take questions one by one. I just got the question from Mr. Deepak Tomar. This question I would like to ask personally. Sir, hope my voice is okay.
Yes, okay, sir. Okay.
Okay. Yeah. The question was Mr. Deepak has asked that do we need harmonic filters for HVAC plant? Still, we have 33 kV mains supply connection. Okay, I would like to answer this question, Mr. Deepak. When we talk about the harmonic filter, the harmonic filter comes into picture when you have variable frequency drives. And as you are aware in HVAC system, variable frequency drives are applicable mainly at three places. One nowadays in chiller motor, compressor motor, what I mean to say, which is fitted in the chiller. Second, it is applicable mainly for the AHU fans. And third, it is applicable mainly for the pumps, where we are installing the variable frequency drives. These are the three places we are generating the harmonics there. Now you are questioning that do we need harmonic filter? See, the harmonic filter comes into picture when you are generating a large amount of harmonics. Large amount of harmonics are not getting generated at the pump for the HVAC plant, for the pumps, not for even the AHU. It is generated mainly at the chiller part. And now majority of these chiller manufacturers are smart enough to take care of it in their own control panel. But again, when the plant capacity goes 500 tons and above each chiller and all, you're running multiple chillers, then I advise you better to take a opinion of your electrical consultant for the project. He will analyze entire electrical load based on the VFDs, and he can advise whether the harmonic filter are really needed or not. I hope you got the answer for this question. Okay, one more question from Mr. Varun. He has asked. Mr. Varun has said, sir, I'm a refrigeration engineer. I wanted to know whereas does the electrical course is structured to HVAC will be helpful to me, and kindly guide me with it, sir. Yeah, I would like to again answer this question to Mr. Varun. Even if you are a refrigeration engineer or HVAC engineer, your roles are more or less same. Your functions are more or less same. You need anyway the compressor. Even if you're in refrigeration, you anyway need the fan coil units which are fitted into the refrigeration. So the basic fundamentals and needs, whatever we have covered in the course remains the same. So this will be definitely helpful to you. And if you don't find it helpful, there is a refund policy which you can apply and ask your refund. Hope I have answered your question, Mr. Varun, satisfactorily. This particular course, anyway, you will find our portal, same portal which you have joined. You will find this particular course, which is the detailed way it's covering all the aspects which are needed for the job pertaining to electrical HVAC. So I'll take again, you are open to ask the questions. Any questions? Any questions are welcome regarding HVAC electricals. So would you please give some insight about the cables of the electrical? How, what is the importance of which type of cables are commonly used for the HVAC system now?
Is that for me?
Yeah.
You see, most commonly used cables are XLPE cables, right?
Yeah.
XLPE means cross-linked polyethylene, the type of PVC which is used, and we use aluminum cables. Below 25 amperes, the cables are 4-core, and above 25 amperes, below 25 square mm size, it is 4-core, and 25 square mm and above, it is 3.5 core. Then how you terminate the cables? Okay, let me explain this, some interesting part for you. Let me go to next slide. I get some space. save करो. Let me give some here. So let me explain to you. We have a cable, okay? Let me go with pointer option, or sorry, pen option. Not coming.
So there are a couple of questions again. I just take them meanwhile.
Let me get this pointer option first.
Yeah. There is one question from Mr. Natarajan Chinnadurai. He asked that whether the online live classes are available for the electricals. Sir, you can answer this about our announcement. You can speak.
That's for me, sir.
Yeah. Here the question is that online classes are the available. Are we having the online classes for this particular section?
Right now, we have no such classes. We're planning to conduct classes on electricals for all those participants who buy our courses. We will support them with classes so that they can understand the subject. If you're going to read it, you might have time, might not have the time, you have difficulty in absorbing the subject. So to make it easy for you, we will conduct online classes, planning to do it on weekends. And when we come to final timetable, we'll communicate to you that we'll run the classes on a specific timetable for all those who have bought our courses. So if you want to understand the subject, the first step.
I would like to summarize this, what sir used to say. We have a lot of courses on an online platform. If you go visit, you can find that there are plenty of courses. Majority of the courses are the recorded version with animation and voiceover or professional voiceover, so that even a very common guy also can understand in very easy language. The purpose we have chosen the part of recorded modules and animated modules to make it very, very affordable for the professionals. If you go for live classes, then you are aware that live classes fees are very high. So to go to even the common person, we are making it recorded version so that they can take it at their own convenience. And we have 12 months support. They can ask us any question, anytime. We are reverting back to them in 24 hours. So that's the reason we have kept it to make it affordable. Our courses are mainly recorded version, but those who are purchasing our courses, we will be conducting live sessions for them to clarify all their doubts.
I'm drawing this for you now.
Yes, sir.
So you have this cable, okay? There are four core or 3.5 core, right? Now this is
so one more question I will take from Mr. Chinnadurai. Sorry to bother you.
No problem.
If you wish to take the whole HVAC course, is it available online? Yes, Mr. Chinnadurai. If you visit our portal, there is a certified MEP professional course which is available at very nominal cost and no cost EMI for 24 months. It is the total course of cost is 9750 Indian rupees or 160 US dollars, which you can equally divide in 24 months. EMI you can choose of the approved bank, whatever types we have, or you can pay in full and you can have that course with certification. Okay, sir. Sorry to bother you. You can ask. You can just cover it up in a couple of minutes.
We have explained each and everything, but it's a small webinar for just for 1 hour duration. So this is also there in the course. Now this is a cable, right? So how do you connect the cable? This is an aluminum lug. Normally we use aluminum lug. It's a lug. It's hollow inside, right? Flat out here, hollow here. Then this will go inside this, right? Go inside this, right? And once you go inside, then what we do is we compress this mechanically. That is called crimping. It is called crimping. You have a special tool, and when you put the aluminum conductor inside the lug, we compress it mechanically for crimping. When you crimp it, the lug, and this is a hole, right? Through this hole, we're connected to the switch. All of our switches have nut bolt connections, okay? The switch bolt will come here, and we'll put a nut here, and we'll fix it. But before we put this cable inside, we put a small paste that is called inhibiting compound. Why you put an inhibiting compound? If you've seen the drawing of the cable, let me show the drawing of the cable. There you are. See, there are so many strands. Strand means 1, 2, 3, 4, 5. There are so many strands. All these are small second conductors bound into one. So there will be air gaps inside. If there's an air gap, if current flows the air gap, then what happens is, then the current starts jumping from one strand to the other strand, resulting in heating. And when heating starts, we get carbonization. And when carbonization starts, then heating increases and this insulation burns out. And when the insulation burns out, we'll get short circuit and fires. So on these strands, this is that strand